Hello and welcome to this episode of KINEMARC's Applied Electricity tutorial session. In this episode, we shall test our understanding of using Kirchhoffs Voltage Law to find currents and voltages in a given circuit. In a circuit as shown, we have a circuit with a number of loops, a number of voltage sources connected to a number of resistors. And the question says we should find the current I in a circuit. I is the current traversing the 3 ohm resistor. Referring to our understanding of Kirchhoff's voltage law, we know that in any closed loop, the sum of voltage sources is equal to the sum of voltage drops. Because a current I has been assigned to traverse the 3 ohm resistor, it can be inferred that there shall be current splits as they arrive at the various junctions. So for the purpose of simplicity, let us name the various points in the circuit. So starting from the very extreme left side of the circuit, we have a 12 volt voltage source in series with a 6 ohm resistor. So we can deduce that the 12 volt voltage source will produce a current, let's say I1. Now current I1 will travel through the 6 ohm resistor through point A and arrive at junction B. So here we still have our current I1. Now between branch B and G, we have a 6 volt voltage source in series with a 6 ohm resistor. Now this 6 volt voltage source will also produce a current, which is current, let's say I2. Now I2 will travel through the branch and arrive at node B and meet I1. Our knowledge in Kirchhoff's current law tells us that at a junction, the sum of currents arriving at the junction is equal to the sum of currents leaving the junction. So between branch B and C, we shall have the sum of I1 and I2 as the current. Now between branch C and F, we have a 24 volt voltage source in series with a 12 ohm resistor. So we can name this as, let's say, X. X because we know the current that will be leaving junction C, because I1 is assigned to the junction or to the path C, D, and E. 2 and 3 are in series, so I is what will also traverse the 2 ohm resistor. So let us find X. Applying KCL, we know that the sum of currents arriving at a junction, which shall be I1 plus I2 plus X, should be equal to the sum of currents leaving the junction. The sum of currents leaving junction C is current I. So we know that our X is I minus I1 minus I2. The reason why we are expressing our currents or our unknown currents using just I1 and I2 is for the ease of finding these currents because of the number of loops we have in the circuit. With just 3 current variables, because there are more than even 3 loops in the circuit, we can easily find for this. So taking loop A, B, J, H, A, that suggests that you are traveling in a clockwise manner. Applying KVL, we know that the sum of voltage sources must be equal to the sum of voltage drops. So our first voltage source here is the 12 volt voltage source. Current from the 12 volt voltage source will leave through the positive terminal of the 12 volts and enter again into the positive terminal of the 6 volts, which is against the general convention that current travels from positive and enters through negative. So here we shall have a minus 6. Now we have the sum, the algebraic sum of our voltage sources. So we shall equate that to the algebraic sum of our voltage drops. Now, current I1 will travel through the 6 ohm resistor. So our first voltage drop is 6I1. And then in branch BG, we have current I2 as what shall be traveling through branch BG. So we shall have, but note, we have the current flow directly opposite to the path we are taking, and so now it shall be minus 6I2. We can further simplify this into 6 equals 6I1 minus 6I2, which is then reduced into 1 is equal to I1 minus I2. So that is for loop ABGHA, and this shall be our first equation. Now let's take loop BCFGB. In this loop, again, we are going in a clockwise manner. We shall equate the sum, the algebraic sum of our voltage sources to the algebraic sum of our voltage drops. So our first voltage source, as seen in the circuit, is the 6 volts voltage source, and the second is the 24 volt voltage source. Now again, the current flow, or the direction of current flow, will be against convention, because current shall travel from the positive terminal of the 6 volts and enter again through the positive terminal of the 24 volts. So if 6 is our reference point, then we shall have minus 24 as the sum, the algebraic sum of our voltage sources, and equate that to our first resistor up here, which is 3, or our first voltage drop up here, which is 3, multiplying the sum of I1 and I2. And then now the direction of the loop is opposite the direction of current flow through the 12 ohm voltage source. So it shall be minus 12 multiplying the expression I minus I1 minus I2. And we have the last one here. I2 is what will travel through the 6 ohm resistor and enter into the voltage source. So we shall have plus 6I2. Let's expand this equation and further simplify it. We have 3I1 plus 3I2 minus 12I plus 12I1 plus 12I2 plus 6I2. Let's group like terms. We have minus 12I plus 3I1 plus 12I1 plus 3I2 plus 12I2 plus 6I2. So we have minus 12I1 minus 12I plus 15I1 plus 21I2, and that shall give us negative 18. So we can have this as our equation 2. So now let's take loop C, D, E, F, C. That is to suggest that we are traveling in a clockwise direction. So the only voltage source in loop C, D, E, F, C is 24, and we shall equate that to the sum of the voltage drops, and we shall equate that to the algebraic sum of the voltage drops in the loop. So we have our first voltage drop that will be due to the 2 ohm resistor, and the current traversing the 2 ohm resistor is current I. So 2I. Again, we have another voltage drop due to the 3 ohm resistor, same current I traversing it, so plus 3I. And our last voltage drop will be due to the 12 ohm resistor. Current traversing the 12 ohm resistor is X, which we found to be I minus I1 minus I2, plus 12 multiplying the expression I minus I1 minus I2. So let's expand and then simplify this equation. 24 gives us 5I plus 12I minus 12I1 minus 12I2. We can further simplify. This is our third equation. So in answering the question, the current I traversing the 3 ohm resistor is 1.8 0.56 ampere. Thank you for watching, and we hope to see you in our next tutorial session.